Evet arkadaşlar, in the last session we had in the class, we were talking about random variables and especially discrete random variables and probability mass function of random variables, cumulative distribution, cumulative uh, distribution function of random variables, right? So we talked about random variables before, we talked about probability mass function, we talked about cumulative distribution function, okay? This was for random variables, discrete random variables, this was discrete, but CDF was always continuous, okay? For all kinds of random variables, whether discrete or continuous, or all the CDFs are continuous functions. So we're dealing with two types of random variables up to now. These are discrete random variables and continuous random variables. So let us look at this example right now. We have a random variable with range 1, 2, or 3. Suppose the PMF of x is given by pk. Pk is equal to 1 over 2 to the power k, or 1 over 2 to the power k. Okay, and k is going to be like 1, 2, or 3, and so on. So let us first plot the PMF of this random variable. For k equals 1, it is 1 over 2. For k equals 2, it is 1 over 4. For k equals 3, it is 1 over 8, and so on, right? So this is k, and this is the PMF or PK of a random variable. So what does that mean? The probability of obtaining 1 as the random variable is equal to 1 over 2. But what's the probability of obtaining 4, for example? It is 1 over 16, which means as the number increases, the probability decreases, okay? That's how it is shown as exponential decrease here. So now if we talk about the CDF of x, what should we be careful about? So for the CDF, if you remember, our function or our um, relationship was like this, right? Let us put here fx of x is like addition of p xk, and xk is less than x, okay? So we were adding the probabilities. For example, for p less than like px less than px less than 1, what's the probability of px less than 1? It is 0, right? What's the probability of px less than 1.5? Here, it's like here. So the probability is below that. So we should check all these values and see there is 1 over 2 probability. For example, for px less than 1 over 1.9 is also 1 over 2, right? I have not surpassed 2 at this still. So if I go to px less than 2.1, now I am somewhere here, so I should add 1 over 2 plus 1 over 4. And when I go to x less than 3.1, for example, or 3.9 or 2.9 here, I should have 1 over 2 plus 1 over 4 plus 1 over 8, right? So if you think about this, we should always like let me say if x is greater than 1 and less than 1.5, if x is greater than 1 and 1.5, if x is greater than 2 and less than 1.5, 2.1, if x is less than, greater than 3, and that means we are always in this intervals. Okay, so in terms of the intervals, how do we plot this CDF? If you plot it like that, before 1, everything is 0. At 1, it jumps. At 1, it jumps to 1/2. Okay, 1/2. And it goes as 1/2 like that until 2, it is 1/2. And after 2, it becomes 1/2 plus 1/4, which means 3/4. It comes here, it is like 3/4. Now I have this, and then until 3, I don't have a value here, but at 3, it is like 3/4 plus 1/8, which is like 7/8. Okay, 7/8. It goes like that until 4, and so on. The final value when k is infinity, this value converges to 1. So until, if we increase k, the final value will be equal to 1, right? So I hope you understand how we go from PK, which is PMF, to CDF, okay? We assign certain intervals, and then we check the probabilities in those intervals. And we also should be aware of the fact that this is the formula that we use. So we take the probabilities before that value, okay? This is like xk is less than x. So this x will be the value somewhere here, okay? It's kind of a threshold as we discussed in the class, okay? So I hope you understand this part. All right, if we continue right now, I would like to focus on this part. What's the probability of x being greater than 2 and being less than and equal to 3? This is a simple question, right? If you look at it thoroughly, like that means p 2 less than or equal to 5, which is equal to p x is equal to 3 plus probability of x is equal to 4 plus probability of x is equal to 5, right? So if you think about that, what's the probability of 1 over, what's the probability of obtaining 3 is like 1/8. This is 1/16. This is 1/32. And I will add all these numbers and obtain 7/32 as my probability, okay? I have added these 3 numbers. What's another way of doing this, arkadaşlar? There is one formula, which is like, depending on the cumulative distribution function, okay? If we are talking about a probability being between 2 values is equal to cumulative distribution function at 5 minus CDF at 2, which is equal to 31/32 minus 3/4, which is equal to 7/32. Okay, so how did we determine this? If you look at, for 3, it was like 15/16. For 4, it was like, here you see the final value is like, this was like 7/8 for probability of like between, let's say 4.9 is going to be equal to 15 over 16. So for probability of 5, it's like 5.9 is going to be like 31 over 32. So this is 31 over 32. This is 3 over 4. So we will be using these kind of formulations also to find out the probabilities between two values. What's the final question? What's the probability of x greater than 4, which is like probability of x equals to 5 plus probability of x equals to 6, and so on, right? Or we may also say that this is equal to 1 minus probability of x less than or equal to 4, right? If we are interested in the probabilities of something greater than 4, which is like 5, 6, 7, we may also say 1 minus p x less than 4. So for probability of x less than 4 is going to be equal to CDF at 4, which is equal to 15 or 16. And we are interested in probability of x greater than 4 is equal to 1 minus 15 over 16, which is equal to 1 over 16. Okay, so this is how we solve such a question. So we looked at pk first, we drew it like that. We understand that it's a kind of, the probability is decreasing when we increase k, and we plotted PMF. Then we plotted CDF using these properties of CDF, and then plotted our CDF like that, right? So this is our CDF function. And then we have calculated certain CDF values at something between 2 and 3, something between 3 and 4, something between 4 and 5, something between 5 and 6, and so on. And then we have used these probabilities and also CDF functions to find out the probability which is asked in the B part. And then this is one of the critical things that I want you to be aware of. Like if we are interested in a probability like that between something and something, then we might use the definitions of cumulative distribution function. Okay. So I hope this was clear. When we think about the probabilities of something greater than something, we might immediately use this formulation. So this was the final exercise for you. And then this is all for the PMF and CDF of discrete random variables. Now, in the next video, I will be focusing on continuous random variables, and then how to find the probability distributions, how to find CDF functions, and so on.